Hello all, my name is Hemant and in this video we are going to discuss part test 6 solutions for mathematics. So let's get started. The first question here is related to inverse of a function where a function is defined as 2x plus 3 by 5 minus 2x. So let's take fx as y and this is 2x plus 3 by 5 minus 2x. Since we say that function y is equal to fx, if we just find out x value as f inverse y, then we can also tell what is f inverse x. So let's cross multiply. This is 5y minus 2xy, that is equal to 2x plus 3, and from here I can write 2xy plus 2x is equal to 5y minus 3. So x can be taken as common, 2y plus 2, that is equal to 5y minus 3. So x value is nothing but 5y minus 3 divided by 2y plus 2. Since x is nothing but f inverse of y, we can also find out f inverse of x by replacing y with x in the above expression. So this is 5x minus 3 divided by 2x plus 2, which is option D. Let's go to the next question. Question number 2 says R is a relation defined if a1 plus ab is greater than 0, and we have to identify the type of relation basically. So for a reflexive relation, the condition is that if a relation is being defined from set A to A, then an element A of this set must be related to itself in the next or the other set. So if I say A R A, then let us see whether the condition is getting satisfied or not. So it will become 1 plus AB will become A square, and this is absolutely correct because 1 plus A square is going to be definitely positive because square of any number cannot be negative. So the minimum value that square can take for real values is 0. So if square is 0, then also 1 is greater than 0. So this is absolutely correct. The relation is reflexive, but be careful. You should also check for the other because there is an option reflexive and symmetric. So for symmetric, if I say A is related to B, then in that case B should also be related to A. So if A related to B means 1 plus AB greater than positive, definitely I can write the same thing as 1 plus BA is greater than 0, because whether it is A into B or B into A, it is the product of two numbers is going to be commutative. So from here I can say that B is also related to A, and therefore it is symmetric. So A and B both are correct, but that both options are present together in option number D. So D is correct, reflexive and symmetric. So you should not check transitive. However, if there was another option like equivalence relation, then you are required to check for transitive, because any relation which is reflexive, symmetric and transitive is equivalence relation. Question number 3 is, let a relation over set n cross n is defined by ordered pair AB related to ordered pair CD if A plus D is equal to B plus C. So here the relation is defined from n cross n to n cross n. It means both the sets are having ordered pairs. So let's suppose AB is ordered pair in the first one, then in second one also we have AB, we can have CD, like that different ordered pairs are there. So AB ordered pair is related to this CD ordered pair. For that there is a rule given. But for reflexive relation, the rule is the same ordered pair must be related to same. It means I can say AB should be related to AB itself. So let's check whether this is true or not. As per the relation rule, A and D, their sum must be equal to the sum of B and C. So taking the first element of the first ordered pair and the last element or the second element of the second ordered pair, A plus B, it is same as B plus A. Therefore, definitely it is reflexive. Okay, it is reflexive relation. Now for symmetric, we have to check if AB is related to CD. We can write A plus D is equal to B plus C. If it has to be symmetric, then C comma D must also be related to A comma B. This is the rule of symmetry. So this C and B must be added up. C plus B should be equal to D plus A, which is correct as per the above one, because A plus D is same as D plus A and B plus C is same as C plus B. So definitely this is symmetric relation also. For transitive, this A comma B if it is related to C comma D, again I can write A plus D equal to B plus C. If this is the case and even C comma D is related to some ordered pair E comma F, then same rule if I apply, C plus F is equal to D plus E, then it is said that since C comma D is the common thing between both these cases, A comma B must also be related with this E comma F. So whether it is true or not, let us try to check. Uh, let's add both of these equations. So if I add left side, then it is nothing but A plus D plus C plus F, and right side it will become B plus C plus D plus E. So if we observe, C and D will get cancelled. So we are having A plus F. It means I can write A and F as the last element of the second ordered pair, A as the first element of the first ordered pair, and then from the right hand side I can say B is the second one and E is here. So I can see this A plus F and this B plus E sum is coming out to be equal, so it is transitive also. So in all the three cases we are getting the conditions satisfied: reflexive, symmetric and transitive. So correct option is D, equivalence relation. Question number 4 is, if the real valued function is even, then the value of n is. So as we know that even function definition is f of minus x is same as f of x. Let's apply here. It will become a power minus x minus 1 divided by minus x to the power n into a power minus x plus 1, that is same as a power x minus 1 divided by x power n a power x plus 1. So to simplify this, let's try to write down this a power minus x as 1 by a power x minus 1 divided by, again depending on whether this n is odd or even, I can separately write minus 1 power n and remaining thing as x power n. Same way, this bracket can be written as 1 by x 1 by a power x plus 1 is equal to a power x minus 1 x power n a power x plus 1. So in the next step I can write this as 1 minus a power x divided by a power x whole divided by minus 1 power n x power n and 1 plus a power x divided by a power x, that's equal to a power x minus 1 by x power n and a power x plus 1. Now let's do all the cancellations. This a power x will be cancelled. Okay, this side we have x power n and a power x plus 1, that will get cancelled away by this term. So from here 1 minus a power x divided by minus 1 power n is equal to, I can take minus common and write 1 minus a power x here also, so that I can cancel 1 minus a power x as well. So whatever we are left with is minus 1 power n is basically minus 1. So if we keep, let's suppose last option 2, minus 1 square will become 1. So that is not a correct answer. And even if I keep 1 by 4, minus 1 power 1 by 4 is not going to give me minus 1. Even if I keep 2 by 3, that will not give me minus 1. So correct answer is 3, because minus 1 power 3 is minus 1. So option A is correct. If angle A is between 630 degree and 720 degree and mod of tan A is 12 by 5, then tan A by 2 is. So let's draw a triangle and let's say this is angle A. So this is 12, this is 5. So as per Pythagoras theorem, this will become 13. And since the angle is 630 to 720 degree, it means 360 degree, one full rotation is completed. And again 180 degree, that is 540 degree. Again 90 degree means it is somewhere here. So it's in fourth quadrant. 630 to 720 degree means we are in fourth quadrant. Okay. In fourth quadrant, tan is negative. So it means tan A value is nothing but minus 12 by 5. Okay. So minus 12 by 5, because tan is negative in the fourth quadrant. tan 2x formula is basically 2 tan x by 1 minus tan square x. So if I apply this, tan a can be written as 2 tan a by 2 divided by 1 minus tan square a by 2. So as per this is minus 12 by 5, 2 times of tan a by 2 value. I am considering it as some capital X, let's suppose. So 2 capital X by 1 minus capital X square, just for the simplicity of calculation. So this is nothing but 12 minus 12 plus 12x square equals to 10x. So 12x square minus 10x minus 12 is equal to 0, or 6x square minus 5x minus 6 is equal to 0. So I can split this 5x as minus 9x plus 4x minus 6 is equal to 0. So 3x common, so it will become 2x minus 3, and here also 2 common, 2x minus 3 equals 0. So in one bracket we'll be getting 3x plus 2, another bracket is 2x minus 3 is equal to 0. So if I write finally this x values here on the left, I am getting minus 2 by 3 and 3 by 2. Okay, so which one we should accept, that is the thing we have to decide based on the angle values. So since a by 2 is in the fourth quadrant, I mean a is in the fourth quadrant, let's decide about a by 2 as well, whether it should be minus 2 by 3 or 3 by 2. However, if you see the options, you don't even have to decide, because there is no 3 by 2 option. Only one option is there, which is matching minus 2 by 3. From there also you can take the decision. In the other way, what you have to do, you can get the information about a by 2 as 315 degree to 360 degree, which will tell you that even a by 2 lies in the fourth quadrant, and therefore tan value has to be negative. So this x was nothing but our tan a by 2, right? So I have to accept this answer. Let's go to the next question. To solve this question, let us apply this formula of trigonometry. Cos 2x can be written as 1 minus 2 sine square x. From here I can write sine square x as 1 minus cos 2x divided by 2. So we have to double the angles, and I can write this as 1 minus cos 2 times of 27 is 54 degree by 2. Same way the next one will become 1 minus cos 87 degree, double angle will become 174 degree, right, divided by 2. And same way it will become 1 minus cos 66 degree divided by 2. So if I take 1 by 2, 1 by 2, 1 by 2 separately, it will become 3 by 2, and then minus half, I can write cos 54 degree plus cos 174 degree and plus cos 66 degree. Then I can take cos 54 and cos 66 degree together, because of their angles. 66 plus 54, if we add, we will be getting 120 degree. So that's a good angle to calculate. Cos a plus cos b formula I am going to apply, which is nothing but 2 cos a plus b by 2 and cos a minus b by 2. So as per that, this will be 2 cos a plus b by 2 will become 60 degree, and a minus b, if I do, it will become minus 66 minus 54. It is difference is 12. In cos, whether you write 12 degree or minus 12 degree, it doesn't matter, and divided by 2 if I do, it will become 6 degree. And this cos 174 is nothing but it can be written as cos 180 degree minus 6 degree. All right, so even this minus half will be as it is. This is nothing but 2 into 1 by 2. So cos 6 degree plus cos pi minus theta is nothing but minus cos theta. So this is going to be minus cos 60, I mean cos 6 degree. So this 2 and 2 cancelled. Cos 6 minus cos 6, this is going to be 0, and we had 3 by 2 over here, so that will be as it is. So this is 3 by 2 minus 1 by 2 into 0. Answer is option B. Let's go to the next question. Question number 7 is cos alpha is equal to 3 by 5 and cos beta is 5 by 13. Then cos square alpha minus beta by 2. So again, we can apply the same cos 2 theta rule, but now in terms of cos square. So 2 cos square theta minus 1. So as per this, I can express cos square theta as 1 plus cos 2 theta by 2. So if I want to write this cos square expression, I can write it as 1 plus cos alpha minus beta divided by 2. So this can be written as 1 plus cos alpha cos beta plus sin alpha sin beta. And very easy question, because now you know cos alpha cos beta values. If I draw a triangle for alpha, this is 3, this is 5, so this is 4. And if I draw another triangle on right hand side for beta, then cos beta is 5 by 13, so this is 5, this is 13, so this will be 12. So by looking at the triangles, I can say sin alpha value will be 4 by 5, and from here sin beta value will be 12 by 13. So I just need to plug in all these values. So 1 plus cos alpha is 3 by 5, cos beta is 5 by 13, plus sin alpha is 4 by 5, sin beta is 12 by 13. This entire thing divided by 2. So it is 1 plus 15 by 65 plus 48 by 65 divided by 2. So this is 65 plus 15 plus 48 divided by 65 into 2. So this is 65 plus 15, 80, 80 plus 48, 128 by 65 into 2. So it's going to be 64 by 65. Option B is correct. Question number 8 is 1 by cos 290 degree plus 1 by square root of 3 sin 250 degree is equal to. So to solve this question, we can write cos 290 degree as cos 270 degree plus 20 degree. Then we can express sin 250 degree as sin of 270 degree minus 20 degree. 1 by cos 270 degree plus 20 degree can be written as 1 by sin 20 degree. The reason is cos 270 plus theta is basically sin theta. And now this next term sin 270 minus theta, since 270 degree is there, sin will change to cos, but 270 minus theta is not in second quadrant, still in the third quadrant, so where sign is negative basically. So this will be negative, plus will be changed to minus, and this is nothing but 1 by root 3 cos 20 degree. So if I solve this, we will be getting root 3 cos 20 degree minus sin 20 degree divided by square root 3 sin 20 cos 20. Now numerator can be written as 2 times of root 3 by 2 cos 20 degree. So I am dividing and multiplying by 2. So this is 1 by 2 again sin 20 degree. And same with the denominator, I can say root 3 by 2, and then again I can multiply 2. So 2 sin 20 degree cos 20 degree. Now this root 3 by 2 I can write cos 30 degree, and this 1 by 2 I can write sin 30 degree. So it is cos A cos B minus sin A sin B. So it is nothing but cos A plus B formula. So it will become cos 50 degree, and this will become root 3 by 2 sin 40 degree, because 2 sin theta cos theta is sin 2 theta. And cos 50 can be written as sin 50 by writing cos 50 as cos of 90 minus 40. I can express it as 2 into sin 40 degree. Okay, so this will give me root 3 by 4 sin 40. Sin 40 sin 40 cancel. This is root 3 by 2 basically. So this 2 will go in numerator. So this is 4 by root 3. Option C is correct. Let's go to the next question. Next question is, if x by y is cos A by cos B, then x tan A plus y tan B divided by x plus y is. So to solve this question, let us utilize the ratio. So for utilizing the ratio, I am dividing this expression by y, so that x by y tan A plus tan B is created, and denominator also becomes x by y plus 1. So if I use cos A by cos B here, and tan A can be written as sin A by cos A. Similarly, tan B can be written as sin B by cos B, and denominator is nothing but cos A by cos B plus 1. Cos A cancelled. So now this will become sin A plus sin B divided by cos b, and this will become cos a plus cos b divided by cos b. So cos b will get cancelled, and the remaining expression, let us try to convert it by formula. Sin a plus b is nothing but 2 sin a plus b by 2, and cos a minus b by 2, and cos a plus cos b is nothing but 2 cos a plus b by 2 and cos a minus b by 2. So this term will get cancelled, 2 and 2. Answer will be tan a plus b by 2, which is option B. Let's go to the next question. Question number 10 is, if 2 tan square x minus 5 secant square x is equal to minus 7 for exactly 9 distinct values of x in closed interval 0 to n pi by 2, where n is natural number, then greatest value of n is. So we can solve this question by putting secant square formula as 1 plus tan square x, that is equal to minus 7. So if I simplify this, this is 2 tan square x minus 5 minus 5 tan square x is equal to minus 7. So sending all the terms to the right side, we'll be getting 3 tan square x, that is equal to 7 minus 5, that is 2. So tan square x is equal to 2 by 3, and tan x value is nothing but plus minus square root of 2 by 3. So for exactly 9 distinct values of x in this given interval, we have to search for greatest n value. So since plus and minus both values are acceptable, 4 distinct values of x we will get. Then again 360 degree if I rotate, again 4 values I will get, and then one more till pi by 2. So this is the case. We have 2 pi plus 2 pi and then again pi by 2 for getting exactly 9 distinct values. So this is coming out to be 4 pi plus pi by 2, which is 9 pi by 2. It means the value of n is 9. Option D is correct. Let's go to the next question. Question number 11 is, if A, B are the length of sides and C is the length of hypotenuse of a right angle triangle, then there is a log expression that is given to us. So A and B are the length of side, C is the length of hypotenuse. So C can be written as square root of A square plus B square. So log, if we separate the numerator terms, log with base c plus b will get cancelled because denominator is also having same term. So we'll be getting 1 by log base c minus a and c minus b, plus the next term log with base c minus b will get cancelled. So in that case we'll be getting 1 by log base c plus b and a here. So now if we use base change formula, this base will become a and this will become c minus b, then plus log base will become a, this will become c plus b, and we can apply the log property, so it will become c square minus b square. So from here Pythagoras theorem, we can write c square is equal to a square plus b square. C square minus b square is nothing but a square. So this is nothing but log base a square. So as per the property, this is 2 times of log base a which is 1. So answer is 2. Option D is correct. Question number 12 is, find the domain of this expression. So anything in the square root has to be greater than or equal to 0. And solve this inequality using sign scheme and all, you can get the answer. But whenever options are given, you can also solve the question within seconds as per the option. Since this entire quantity inside the square root needs to be positive, just imagine if we are using x is equal to 1, in this x will be positive, x plus 2 will be positive, x plus 3 square will be positive, but this 1 minus e power 1 is negative because e is approximately 2.718. So this term will be negative, and all the terms, all the positive terms multiplied with single negative term here will turn out to be negative. So definitely x equal to 1 cannot be a part of domain, but if you see option A, minus 2 to 3, 1 will be present. Here also 2 to 0. First of all, it is not written properly. It has to be 0 to 2, but anyways, even if I take 2 to 0, then also 1 is a part of that domain, which is wrong. And if you observe option D also, 0 to 3, in that 1 is counted, so option D also is wrong. Option C is correct. Question number 14, the given function is on to, we have to find the interval of alpha. So let's take fx as y. So this is alpha x square plus 6x minus 8 divided by alpha plus 6x minus 8x square. If we cross multiply this, alpha y plus 6xy minus 8x square y is equal to alpha x square plus 6x minus 8. If we write this in x square, this will become alpha. So these two terms I am writing together by taking x square common. So alpha plus 8y times x square. Then next x terms I am trying to collect. So 6x we have. So 6 minus 6y times of x. From the left side I have adjusted. And then the remaining term minus alpha y minus 8 is equal to 0, or I can use a bracket and write here plus. So this is a quadratic in x. For x belonging to real number, which is clear from the domain, the discriminant has to be greater than or equal to 0. So 6 minus 6y b square minus 4ac, which is alpha plus 8y, and this c is negative also, so plus alpha y plus 8 has to be greater than or equal to 0. So this is 36 minus 72y plus 36y square, and 4 times of this alpha into alpha y, that is alpha square y, then again alpha into 8, that is 8 alpha into 4, 32 alpha, then again 8y into alpha y, that is 8 alpha y square into 4, 32 alpha y square, and finally 8y into 8, 64, 64 into 4, that is 256y has to be greater than or equal to. So after arranging all the terms in the form of quadratic in y, we are getting this. For any quadratic to be positive, okay, for any quadratic to be positive, its leading coefficient must be positive and d value must be less than 0. So if I calculate the d value for this, it is going to be alpha square plus 46 whole square minus 9 plus 8 alpha, 4 times of 9 plus 8 alpha into 9 plus 8 alpha, which is 9 plus 8 alpha square. This has alpha square plus 46 whole square minus, I can send this 4 inside the bracket as a 2 because there is a square already on the bracket. So it will become 18 plus 16 alpha whole square less than 0. So this is a square minus b square. I can write a minus b and a plus b together also. So alpha square plus, I'm going to add, so this is 16 alpha, 46 and 18 will become 64. Okay, so this is a plus b. Then next one is a minus b. If I do a minus b, it will become 46 minus 18, 28, and this will become minus 16 alpha plus 28 less than 0. So this is nothing but alpha plus 8 whole square. It is going to be positive anyways. Alpha minus 14 less than 0. So on number line we are having 2 and 14. So this is plus, this is minus, this is plus. So for negative values, you can take from 2 to 14. So there is no equal to 0 here. D has to be less than 0. So it should be open from 2 to 14. So correct answer is option D. Question number 15. It is given that function is an even function and set of values of a is what we have to determine. So for even function, f of minus x is equal to fx. Or I can also say fx minus of f of minus x needs to be 0. With this logic, I can write the expression as greatest integer of x square by a sin x plus cos x minus f of minus x, still this will be x square by a sin x. This is fx, and then next one we are going to write is f of minus x. So this is again plus cos of minus x. Since cos of x and cos of minus x is same, so due to this minus, cos x term will get cancelled and we'll be left with box of x square by a sin x, because sin of minus x, this minus will come out and make this plus. So 2 times of this is equal to 0. Again 2 will go to the right side. So we are left with box of x square by a sin x is equal to 0. So for getting the a values, sin x also can be 0 for some x values, but since we have to get the set of x a values, so we can put the box of x square by a equal to 0. It means x square by a will take values from 0 till just before 1, like 0.99, because for that also box or greatest integer value is 0. It's positive, I can say that x square value will be greater than or equal to 0 and less than. Since x belongs to minus, from minus 20 to 20, the square value will be from 0 to 400. So a is greater than x square values also. So if I take x square as 400, then a is greater than that also. So definitely if I take x value as 0, I mean x square value, the minimum one as 0, then I can say a is greater than 0 also. So in any case, if I combine this, I'm getting a values to be greater than 400 itself. So that is there in option number B, which is 400 to infinite. Question number 14, the given function is on to, we have to find the interval of alpha. So let's take fx as y. So this is alpha x square plus 6x minus 8 divided by alpha plus 6x minus 8x square. If we cross multiply this, alpha y plus 6xy minus 8x square y is equal to alpha x square plus 6x minus 8. If we write this in x square, this will become alpha. So these two terms I am writing together by taking x square common. So alpha plus 8y times x square. Then next x terms I am trying to collect. So 6x we have. So 6 minus 6y times of x. From the left side I have adjusted. And then the remaining term minus alpha y minus 8 is equal to 0. Or I can use a bracket and write here plus. So this is a quadratic in x. For x belonging to real number, which is clear from the domain, the discriminant has to be greater than or equal to 0. So 6 minus 6y b square minus 4ac, which is alpha plus 8y, and this c is negative also, so plus alpha y plus 8 has to be greater than or equal to 0. So this is 36 minus 72y plus 36y square, and 4 times of this alpha into alpha y, that is alpha square y, then again alpha into 8, that is 8 alpha into 4, 32 alpha, then again 8y into alpha y, that is 8 alpha y square into 4, 32 alpha y square, and finally 8y into 8, 64, 64 into 4, that is 256y has to be greater than or equal to. So after arranging all the terms in the form of quadratic in y, we are getting this. For any quadratic to be positive, okay, for any quadratic to be positive, its leading coefficient must be positive and d value must be less than 0. So if I calculate the d value for this, it is going to be alpha square plus 46 whole square minus 9 plus 8 alpha, 4 times of 9 plus 8 alpha into 9 plus 8 alpha, which is 9 plus 8 alpha square. This has alpha square plus 46 whole square minus, I can send this 4 inside the bracket as a 2 because there is a square already on the bracket. So it will become 18 plus 16 alpha whole square less than 0. So this is a square minus b square. I can write a minus b and a plus b together also. So alpha square plus, I'm going to add, so this is 16 alpha, 46 and 18 will become 64. Okay, so this is a plus b. Then next one is a minus b. If I do a minus b, it will become 46 minus 18, 28, and this will become minus 16 alpha plus 28 less than 0. So this is nothing but alpha plus 8 whole square. It is going to be positive anyways. Alpha minus 14 less than 0. So on number line we are having 2 and 14. So this is plus, this is minus, this is plus. So for negative values, you can take from 2 to 14. So there is no equal to 0 here. D has to be less than 0. So it should be open from 2 to 14. So correct answer is option D. Question number 15. It is given that function is an even function and set of values of a is what we have to determine. So for even function, f of minus x is equal to fx. Or I can also say fx minus of f of minus x needs to be 0. With this logic, I can write the expression as greatest integer of x square by a sin x plus cos x minus f of minus x, still this will be x square by a sin x. This is fx, and then next one we are going to write is f of minus x. So this is again plus cos of minus x. Since cos of x and cos of minus x is same, so due to this minus, cos x term will get cancelled and we'll be left with box of x square by a sin x, because sine of minus x, this minus will come out and make this plus. So 2 times of this is equal to 0. Again 2 will go to the right side. So we are left with box of x square by a sin x is equal to 0. So for getting the a values, sin x also can be 0 for some x values, but since we have to get the set of x a values, so we can put the box of x square by a equal to 0. It means x square by a will take values from 0 till just before 1, like 0.99, because for that also box or greatest integer value is 0. It's positive, I can say that x square value will be greater than or equal to 0 and less than. Since x belongs to minus from minus 20 to 20, the square value will be from 0 to 400. So a is greater than x square values also. So if I take x square as 400, then a is greater than that also. So definitely if I take x value as 0, I mean x square value, the minimum one as 0, then I can say a is greater than 0 also. So in any case, if I combine this, I am getting a values to be greater than 400 itself. So that is there in option number B, which is 400 to infinite. So y is equal to sine power 6 plus cos power 6 can be written as sine square x plus cos square x whole cube minus 3 sine square x cos square x. That divided by sine power 4 plus cos power 4 can be written as sine square x plus cos square x minus 2 sine square x cos square x. So if we try to solve this, this is 1 minus 3 sine square x cos square x divided by 1 minus 2 sine square x cos square x. Since 2 sin x cos x is sine 2x, I can also express this as 1 minus 3 by 4 square 2x. Okay. And denominator also can be written as 1 minus square 2x. So this will become 4 minus 3 sine square 2x divided by 4 minus 2 sine square 2x. That is y. And we can get 4y minus 2y sine square 2x equal to 4 minus 3 sine square 2x. So taking the similar terms together, 4y minus 4 can be written as sine square 2x common 2y minus 3. From here I can say 4y minus 4 by 2y minus 3 is the value of sine square 2x, and sine square value will be lying between 0 and 1. So we need to solve this inequality. So for greater than 0 case, if we solve, we are getting critical point as 1 and 3 by 2, and it will be plus minus plus. We want greater than 0, so it will be before 1 and after 3. And if we solve the second case, 4y minus 4 by 2y minus 3 minus 1 less than or equal to 0, we will be getting 2y plus 3, so it will be minus 1 by 2y minus. So from here we will be getting critical points as 1 by 2 and 3 by 2. Again this is plus minus plus. We want negative, so it is 1 by 2 to 3 by 2 with 3 by 2 open, because denominator cannot be 0, and 1 by 2 closed. Now if we see the common solution, the first solution is after 3 by 2. So after 3 by 2 we cannot take, because in second case we have not got any solution after 3 by 2. So it has to be before 3 by 2, which is the case before 1 here in the first solution. So the common portion if you take is nothing but 1 by 2 to 1. Okay, 1 by 2 to 1, that is the range of this question. If you check the option, pi by 8, 3.14 by 8 is less than half. Similarly, 3.14 by 7 is less than half. Pi by 6 is little bit greater than 0.5, so it can be an option which we can mark as correct. Given option D lies in the given range. Number 17 is if cos A is equal to 3 by 5 and tan B is equal to 12 by 5 and neither A nor B lie in the first quadrant, then we have been given with several options. So since A and B, they are not in the first quadrant, for that case let us try to get some values from cos A equal to 3 by 5. So if I want to write sine A, if this is the angle A, this is 3, this is 5, this will become 4. So sine A is nothing but 4 by 5. The chance that sine A can be plus 4 by 5 or minus 4 by 5, correct? So 4 by 5 will be discarded because A is not in the second quadrant also. And how to understand it? Because cos was positive. So cos can be positive only in the first quadrant or the last quadrant. So definitely A is somewhere in the last quadrant where sign is negative. So minus 4 by 5 is what I have to take from there. Similarly, if I discuss from tan B is equal to 12 by 5, again if this angle is B, this is nothing but 12 by 5. So hypotenuse, if I calculate, that will be actually 13. Okay, that will be 13. So again tan is positive, which means B is somewhere in the third quadrant, because definitely B is not in the first quadrant. It has to be in the third quadrant for tan to be positive, and in third quadrant sine and cos both are negative. So if I want sine B, it will be minus 12 by 13. If I want cos B, it will be minus 5 by 13. So I think based on this, if we can calculate sine A plus B, sine of whether it is getting positive or negative from here. So sine A value minus 4 by 5, cos B value minus 5 by 13. Then sine B value is minus 12 by 13 and cos A was 3 by 5. If I calculate this, 20 by 65 minus 36 by 65, definitely it is negative. And if sine is negative, sine A plus B is negative, and if we calculate cos A plus B similar way, cos A cos B minus sine A sine B, we'll get some idea from here also. So cos A cos B is 3 by 5 into minus 5 by 13 minus sine A is minus 4 by 5, sine B is minus 12 by 13. Again we are getting minus 63 by 65. So sine and cos both are negative for A plus B. So definitely it cannot be first quadrant, and definitely it cannot be second and fourth quadrant, because in second sine is positive, in fourth cos is positive. So the only possibility is in third quadrant. So option C is correct. Let's go to the next question. The question is number of integers in the range of this function. So for fx to be defined, x should not be an integer multiple of pi by 2. So to solve this question, I can write this as y is equal to sine 3x cos x plus sine x cos 3x divided by sine x cos x. So it is sine A cos B plus sine B cos A formula, which is nothing but sine A plus B, which is sine 4x. Okay, and if I divide by 1 by 2 and multiply with 2 sine x cos x can be written as sine 2x. So this is nothing but 2 times of sine 4x by sine 2x. Now sine 4x can be written as 2 sine 2x cos 2x. Okay, as per sine 2 theta formula. So sine 2x will get cancelled. So this is nothing but 4 times of cos 2x. Cos can take values from minus 4 to 4. So we have minus, but since cos x cannot be 0, otherwise this denominator will become 0. For that purpose, I can say that cos x should not be equal to 0. So therefore, x should not be a multiple of pi by 2. I mean integer multiple of pi by 2. It means 2x cannot be equal to n pi. So cos 2x, depending on integers, this could have been cos n pi where n is even, and this could have been cos n pi where n is odd because n is an integer. So this cos 2x would have given us 1 or minus 1 as answer. So definitely we are getting minus 4 to 4. In that you can count minus 4, minus 3, minus 2, minus 1, 0, then 1, 2, 3, 4 as the integers, and you may give answer as 9 also if you don't be careful. But actually 1 and minus 1 answers are not possible, so you have to discard them. So only 3 on this side, then 2, 3, 4, and in middle we have 0. So total 7 answers are possible, or 7 integers are possible. Correct option is B. Question number 19 is the sum of all the roots of the equation is equal to. So sine inverse x plus cos inverse x, whenever x values are from minus 1 to 1, can be written as pi by 2 as per the inverse trigonometry properties. So I can say the tan inverse part, which is x square minus 3x plus 3, can be written as 3 pi by 4 minus pi by 2, which is nothing but pi by 4. So this will be x square minus 3x plus 3 is equal to tan pi by 4, which is 1. So x square minus 3x plus 2 is equal to 0. So x minus 1 and x minus 2, that is equal to 0. From here we are getting x equal to 1 and 2, two possibilities. But as I said, for the domain of sine inverse and cos inverse, x values has to be between minus 1 and 1, including minus 1 and 1. So 2 cannot be possible, so only possibility is 1. So the roots for this equation is only 1, and that is 1 itself. Option A is correct. Question number 20, we have a set where 9 power 1 minus tan square x plus 9 power tan square x should be equal to 10. Satisfying this, we have to keep x values, and that also from minus pi by 2 to pi by 2. And there is a beta expression based on which we have to find 1 by 6 times beta minus 14 whole square. So let's put 9 power tan square x as y, written as 9 by 9 power tan square x plus 9 power tan square x, that is equal to 10. So from here 9 by y plus y is equal to 10. So this is nothing but y square plus 9 is equal to 10y. So that means y square minus 10y plus 9 equals to 0. So let's solve. This is 9 power tan square x value. Again 9 power tan square x value, that should be 9. So from here I am getting tan square x is equal to 1. And from this case tan square x only possibility is 0, because 9 power 0 will give us 1. So x value is 0 in this case, because x has to be between minus pi by 2 to pi by 2 only. Otherwise there are other values of x also for which tan will be 0. Now tan x is equal to plus minus 1 in this second case. For minus 1 we have minus pi by 4, and for 1 we have pi by 4. So only two possibilities here as well, based on the x interval that is given to us. So beta can be found as summation of tan square x by 3 terms. It means we have to do tan square of 0, then tan square of minus pi by 4 divided by 3 will become minus pi by 12. Since we are squaring, that will also turn out to be positive, okay, because tan, these are the x values, okay. So x by 3 is what we have to calculate. So this is minus pi by 12 and this is pi by 12. So if I take tan minus pi by 12, that minus due to squaring will again be cancelled only. So this is tan square pi by 12 and again tan square pi by 12. This is the beta value that we will be getting. Pi by 12 is nothing but 15 degree, and you should remember that tan 15 degree value is nothing but 2 minus root 3 if we simplify. So 2 minus root 3, if you don't know how to solve, you can apply tan 45 degree minus 30 degree. From there you can get the values and rationalize it basically. So if I use the values, this is 2 times of 2 minus root 3 whole square, which is nothing but 2 times of 4 plus 3 7, 7 minus 4 root 3. And they have asked 1 by 6 times of beta minus 14 whole square. So beta value is 14 minus 8 root 3. From this if I subtract 14, this 14 will get cancelled, only minus 8 root 3 will be remaining. So if I square that one, we will be getting 64 into 3 and divided by 6. So this is nothing but 64 by 2, which is 32. Option D is correct. Question number 21 is the sum of all the elements in the set where HCF of n and 2040 should be 1. So for this condition, let's see 2040 is having what numbers in its prime factorization. So this can be written as 2 cube into 3 into 5 into 17 if you do the prime factorization. So if we want HCF of n and 2040 to be 1, then the element n should not be from 2, 3, 5 and 17. That is the case. So n should not be a multiple of 2, 3, 5 and 17. So I'm not taking the sum of even numbers, because then 2 will be coming into picture. So definitely that in the required sum we have to take 1, 3, 5, so on till 99. But even from that I need to subtract the multiples of 3. So 3 plus 6 plus 9. But be careful, since we have already removed the even numbers. Again writing 3 plus 6, that will be wrong, because 6 you have already removed. There is no 6 present in 1 plus 3 plus 5. So over counting while subtraction will lead to a wrong answer. So 3 plus, directly you have to take 9, because 9 is there from 1, 3, 5, 7, 9. 9 will be a part of that. So you have to take the multiples of 3, but you should not take even numbers. So after that, next will be 15, then 21, and so on till 99 you can go. Again minus the multiples of 5. Be careful here also, because after 5, if you think the multiple of 5 as 10, then it will become wrong, because 10 was already removed in the beginning itself. I did not even take any even number. So 10 should not be taken. Even 15 is a multiple of 5, but 15 is already removed. So no need to remove the same thing again and again. So it has to be 20 then. No, 20 is also an even number. So next one is 25. So like this, after 5, we have to take 25. Then it is 35, not 30. Then it should not be 40 also. Then next one should not be 45, because it is a multiple of 3. Then it should not be 50 also. So it should be 55. So like this, you have to take 65, then 85 and 95. So this can be manually done also, because there may or may not be pattern sometimes. And in 17, there is only one number which is a multiple of 17 in 1 to 100, that is 17, which can be removed, because 34, the next one, is already removed. 51 is a multiple of 3, already it will be removed in this second bracket. Then 68 is again even number, we did not even take it. So likewise 17 is the only thing that you have to worry about. If you solve this 1 plus 3 plus 5 with the help of sum of AP, you will be getting this as 2500. Similarly 3, 9, 15, 21, this is also an AP with common difference 6. If you solve that summation, you will be getting 867. And if you solve this addition of all multiples of 5, this is 365, and then minus 17, you will be getting the final answer as 1251. Question number 22, A, B and C, three different sets are given with different conditions. We have to find number of subsets of the complement of A, B and C, and then take an intersection with the set of integers. So let's solve the first set. For x minus 2 mod to be greater than 1, x minus 2 has to be less than minus 1, or x minus 2 has to be greater than 1. So this means x has to be less than 1 or x has to be greater than 3. This is the condition for set A. Similarly, solving for set B, we will get another condition, and that is by squaring the both sides, we will get x square minus 3 greater than 1. So that is x square minus 4 greater than 0, which is x minus 2, x plus 2 greater than 0. On number line, we have minus 2, 2. So plus minus plus, left of minus 2 and right of 2, that is the solution part for set B. Similarly for C, I have to write x minus 4, either it will be less than minus 2 or it has to be greater than or equal to 2. So x will be either less than 2 or x will be greater than or equal to 6. So if we plot all of them on number line to get the common solution, I have to write minus 2, then 1, then 2, then 3, and then 6, right? I think we should not miss any numbers. So that's it. So A answer is less than 1 or greater than 3. So let me mark A also. Then B answer is less than minus 2. This is B answer, or greater than 2. This is B answer. And C answer is less than or equal to 2. Okay, less than or equal to 2, or it has to be greater than or equal to 6. This is C answer. So if we search for the common portion, for the common portion, this is the common till minus 2, and then we have common after 6, right? Now from this common portion, if I write A intersection B intersection C, it will be minus infinite to minus 2. Minus 2 should not be closed because here it is closed in C, but what about the A and B part? There 2 is not really included. I mean, in A also minus 2 will be coming in the solution, but for B, if you observe, it is open interval, correct? So common means it has to be there in all the three sets, so that's why I'm keeping it open. And the other part which came common was after 6 to infinite, but 6 is open or closed, that we have to figure it out. So if you observe the A solution, x is greater than 3, so 6 will be a part. Here for B, it has to be greater than 2, so 6 will be a part. And in C also, x is equal to 6, so I can take it equal to. Now if I take the complement from minus 2 to 6, we will get the answer A, B, C intersection, and then complement means since minus 2 was not a part of intersection, now minus 2 will be the part of the complement, and earlier 6 was a part of the intersection, so it will not be part of the complement. So minus 2 to 6, if we take the intersection and then complement, we'll be getting the answer. But now we have to take intersection with integers, and then if we count number of elements, we have minus 2, minus 1, 0, 1, 2, 3, 4, 5. So we have total 3 and 3, 6 and 2, 8. 8 elements are satisfying, and number of subsets formula is 2 power number of elements in that set. So 2 power 8 is nothing but 256. That is the number of subsets for this given case. Question number 23 is the number of elements in the set where n belongs to integer and modulus of n square minus 10n plus 19 is less than 6. So as we know that mod of x less than a implies x values will be from minus a to a. So using that rule, I can say this is minus 6 to n square minus 10n plus 19 value till 6. So I have to solve basically two part. First one is n square minus 10n plus 25 will become greater than 0, and the second part is n square minus 10n plus 19 minus 6, which is 13, so that is less than 0. So this one is nothing but n minus 5 whole square greater than 0. Now to solve this inequality, I just require the alpha beta roots where alpha and beta, where beta is greater than alpha. So this will become plus, minus, plus. So I just need to count the integers between alpha and beta as per this inequality. So let's get alpha or beta, I mean n values. So it's 10 plus minus square root of b square minus 4ac divided by 2 times of coefficient of n square, which is 2. So this will become 5 plus minus square root of 48 can be written as 4 into 12, so that 4 I have taken out, it will become 2 and got cancelled, so only 12 is remaining. So alpha is nothing but 5 minus square root of 12 and beta is nothing but 5 plus square root of 12. So this can be written as 5 minus 2 root 3 and this is 5 plus 2 root 3. So root 3 can be taken as 1.7 approximately. So 5 minus 3.4, that is 1.6, and this is 5 plus 1.7 into 2, again that is 3.4, so it is 8.4. 7 integers that you can count from this expression, but 5 you have to eliminate because as we have seen at n is equal to 5 there is a problem. Although I have written n belonging to all integers, but at n equal to 5 it will become 0 greater than 0, which is not true. So at n equal to 5 this is wrong, so that 5 you have to discard, otherwise 2, 3, 4, 6, 7, 8, these are the 6 values, so correct answer is 6. Let's go to the next question. With two curves we have to find point of intersection. So if I square the first one, it is nothing but a circle with center 0, 0 and radius 1. Although I can observe that it is a circle, I should not be drawing the entire circle because y was equal to square root of 1 minus x square. Square root of anything in real number cases is going to be positive. So definitely y coordinate has to be greater than or equal to 0. So only this first quadrant, second quadrant portion of the circle has to be taken. And as we know that sin x graph, if we draw, it will be going from 0 like this again till here. So this is pi, this is 2 pi, and it will come down and again, so it will keep repeating after 2 pi, but if you see the point of intersection, there is only one point of intersection, because this dotted portion of the circle is anyways not included in the actual graph, which is y is equal to square root of 1 minus x square. So the correct answer for this question is 1. Question number 25 is the number of points where the curve cuts the x-axis is. So basically at x-axis y will become 0. That is what we have to figure it out. So let's try. We have three different critical points. The critical points are x plus 2 if I put 0 minus 2, then x plus 1 if I put 0 minus 1, and x minus 2 if I put it equal to 0, that is 2. So if I use x values greater than 2, in that particular case, for x greater than or equal to 2, my function value fx will be equal to 2 times of x plus 2, the mod can be removed easily, then minus 3 times of x plus 1, and even the last one can be removed as it is, so it is x minus 2. If I simplify this, I will be getting 2x plus 4 minus 3x minus 3 plus x minus 2. So it is 4. So 2x plus x, 3x, 3x minus 3x cancelled. 4 minus 3 is 1. 1 minus 2 is minus 1. So we are getting minus 1. So it is not going to cut x-axis for any values greater than 2. Now for x belonging to minus 1 to 2 open, if we observe. So for that case, function fx can be written as, so minus 1 to 2, still the first mod will be positive, right? So it is 2 times of x plus 2. The second mod will also be positive, okay? So this is 3x plus 1. But the last mod, if you observe, if I use anything between minus 1 and 2, which is, let's suppose 0, it will become negative, so it has to open with a minus sign. So let me solve this. This is 2x plus 4 minus 3x minus 3 minus x plus 2. So 2x minus x, that is x minus 3x minus 2x, and 4 plus 2, 6. 6 minus 3 is plus 3. So even if I try to put fx equal to 0, because cutting x-axis means y has to be 0, I will get x value as 3 by 2, and 3 by 2 lies inside the given interval for which we are solving this case, right? So it is acceptable. So one value we have got where fx will be equal to 0. Now let us try for the x values belonging to minus 2 to minus 1. Now minus 2 to minus 1, still the first one will be positive, so 2 times of x plus 2, but second one will be negative. This x plus 1 will become negative in this interval, so it is going to open with minus, so it will become plus 3 times of x plus 1. And even the last mod term, which is x minus 2, that will also become negative, so it has to be minus of x minus 2. So 2x plus 4 plus 3x plus 3 minus x plus 2. So 2x, 3x, 5x minus x, 4x, and 4 plus 3 plus 2, that is 9. So if I try to put it equal to 0, I will be getting minus 9 by 4. Okay, if I put it equal to 0, from there x value is minus 9 by 4, which is minus 2 point something. So that is not possible because we have started from minus 2 to minus 1. So this answer we cannot take. Even though we are getting fx equal to 0, I cannot accept this value. So till now we have got only one value. Now last thing is, if I take x values less than minus 2, in that case all the terms inside the mod will become negative, and we can open with a negative sign. So it is minus 2 times of x plus 2 plus 3 times of x plus 1, and minus of x minus 2. So minus 2x minus 4 plus 3x plus 3 minus x plus 2. So 3x and minus 3x will cancel, and we will be getting 1, and therefore I can say only one point is there, which is 3 by 2, at which the graph will cut the x-axis. So that's it. With this, part 6 discussion is over. Thank you.